Alright, hi guys. So this is a kite. And the properties that you need to know about kite are that these two sides are congruent and those two sides are congruent. And then the diagonals form sorry, a 90-degree angle, so that means they're perpendicular to each other. And let's see, the diagonals, the long one bisects the shorter one, so that means this part is congruent to that part. So this creates two sets of right triangles, and it also creates kind of an isosceles triangle on the top and an isosceles triangle on the bottom. So what ends up happening is, actually before I get to that, the long diagonal also divides the bottom and top angles in half. So that means that this angle down here next to D is congruent to that one. And then up here, the B angles, those are congruent to each other. So then we have an isosceles triangle. Let me kind of shade this in. So, ooh, that's kind of funky. So we've got this triangle up here, and that's an isosceles triangle. So what we can do then, let me get rid of that now, is if we know those two sides are congruent, that means that its base angles are congruent. So that that angle is congruent to that one. And then we have the other isosceles triangle down here, this one. And that means that that base angle and that base angle are congruent to each other. And that is it. So go ahead and turn to the next page and let's do some examples. So again, the top part on there, just write see other page. But if we look at example A, sorry, my copy is not very pretty, but it says if WXYZ is a kite, find the measure of ZX. So we're looking for this right here. So it's looking for the length of that diagonal. So if we know that this part is 5 from there to there, then the whole thing would be 10 because we know that that is congruent to that part. So example B, again we have a kite and it says find the measure of angle X. So we're looking for this right here. And it even shows on our figure that our congruent sides. And what ends up happening is, because it's a quadrilateral, we know that the sum of the angles is 360. So we can use that to our advantage. I'm going to go back to the other page for a second. So if you guys notice, let me get a different color here. On our kite, you should notice that that big angle A, like the little part plus the bigger part, is congruent to that one. So those are the same. I mean, it kind of makes sense with the two parts that you're seeing that are the same, but just a reminder. So if we go back to our example here, this comes into play because we have two angles. We know one is 70, we know one is 56, and what happens is that angle X is congruent to that angle Z. So since those are the same, we can do 360 minus the 70 minus the 56, which gives us 234. And then, so that gives me both of those, so this angle and this angle, so the angle X and the angle Z together equal 234. And so since they're the same, we can do 234 divided by 2, which gives me 117. And just as a friendly reminder on problems like this, see if something seems reasonable or not. So if that had been an acute angle, you'd know that the 117 is an unreasonable answer. but it's kind of obvious from the drawing that, not that it's to scale, but it's, you know, a close estimate that it's an obtuse angle, so 117 is reasonable for angle X to be that. And that's it. So go ahead and do the, I believe it's just the next page, and that's it.